welcome back. This is what we ended up with. Last time we had our nucleus made, we had our electron, all of our sprites were arranged how we wanted them. Now we're going to look at moving this in an orbit or circle, or actually more like an ellipse. Okay, but we'll see how that works out as we go. First things first, let's play about with our nucleus. Okay, we want our electron to move because in nature, in the real world, so to speak, the electron moves and the nucleus stays where it is. And there's two things that we can do. Well, there's loads of things that we could do, but there's two things that we're going to look at doing with our nucleus first. Okay. First thing, notice how we're going to have to worry about the proton and the neutron separately, but that's not a problem because they'll be doing mostly the same thing. Let's start with our proton. Come down here, click on our proton, so we know that whatever we're programming is actually being programmed to our proton and not something else. We want everything to begin when we click the green flag. To do that, we go down to events over here. Choose the first one when green flag clicked. This means that whenever we click the green flag, everything underneath here that we can add will begin to run. Okay? And again, for the purpose of what we're doing, we just want it to run indefinitely, forever. Okay? When we click the green flag, whatever we tell it to, we just want it to happen over and over and over again. To do that, we go to control. We come down to the third one here, which says forever. We attach that. Now, anything we put inside this forever block will just keep happening over and over and over again. And when it starts nice and simple, we just want our proton to stay where it is. It's at position X, -6, Y is 3. Now we can change these if we want so that it's in the middle exactly. And then we can change the position of our neutrons to sort of match that. So let's say 20, maybe that'll be it. And then drop it down to maybe 20 as well. Oh, wrong way. Oh, maybe a little bit higher. Higher again. Something like that. That'll do. Okay. Either way, whatever positions we got here, this is where we want them to stay. And if we go to motion and find the block that says go to, not to go to random, but go to X and Y. And you notice that these values here match these values here. Take that, put that in there, and then we can do the same thing but for the neutron. We click down here on neutron, we're going to go to events, when green flag clicked, control, forever, motion, and you notice now these X and Y values have changed to match the neutron's X and Y values. We'll put that in there. Now, when I click the green flag, I can move these, and they will always end up going back to where they started. Okay, or I can move them before I start, the green flag, and they go back. Now you might end up with this little weird overlap depending on which one you move first and second. All we can do to counter that is go down to proton and we can go to looks and we can find the block that says go to front layer. Put that in there. Okay, and now we can remove the same thing, we'll go back to the start and then voila. Now this one will always be in front. Okay, but that's a little extra, that's not really important. As long as you remember to move the proton last, it'll always end up in the front anyway. Okay, so that's what we're going to do with the proton and neutron. Now we'll come back to those in a little bit and do something else with them. But for now, we're just going to do that. For our electron, however, click on our electron, we want to do something a bit different. We don't want it to stay where it is, we want it to move. We want it to turn a circle around our nucleus. Okay? It's going to be the same starting spot. We're still going to use when green flag clicked, and we will still use a forever block. But how we get it to move is different. Now we can, if we wanted to, use one of these go-to blocks, as long as we don't put it inside the forever, and it'll start in the same place every time, but we don't need that, so I'm not going to use it. Now what we want to do, okay, so we want to make it turn in a circle. And there's a few blocks we can use to actually move our sprites. We can use this move 10 steps block, we can use the turn blocks, depending on how many and how you use them. You can even use these ones, these go to and glide blocks. But what we're going to use is turn. Okay? And we're going to put turn in there. We don't want 15 degrees, we can actually just change it to 1. And we'll show you something a little bit different towards the end about these turn degrees, but for now we just want to turn 1. What this is going to do is it's going to change this number down here, this direction, by 1 every time. It's going to go back, it's going clockwise. Okay, what that means is, if you imagine, we bring this over here to front and center, we imagine there's a little arrow on this electron. This arrow is currently pointing this way, towards the right hand side to my screen. That's direction 90. When we run this turn, as this number changes, that arrow changes and is pointing in a different direction every time till it gets back to the beginning. It'll reach 360 and then go back to 0, and so on, so on, so on. And what we actually want to do is almost like animation, in the sense that we want to take a snapshot of every single section of that circle. A circle has 360 degrees. We're moving 1 degree every time we change this number, so we're going to have 360 different sections, 360 different snapshots. What we want is, we want to tell our electron to go to each individual snapshot every time it changes. So that'll go from 90 to 91, and then we'll go to the 91 snapshot, then 92 snapshot, 93, 94, 95, and so on. Eventually, we will actually form a circle. And the best way to do that is to use trigonometry, sine and cosine. Okay, now don't worry too much if you've never done sine and cosine. Don't worry if you've done it and you don't like it, or you can't quite figure it out. You don't need to understand how it works for this. Because the beauty of programming, the beauty of something like Scratch, is that it will do it all for you. Okay, now we'll go through step by step how to actually do it. But what we will end up doing is, once we've got everything set up, we will be telling our electron to go to each individual section of our circle every time this number changes. Every time this number changes by 1, it's going to go to a different section. Okay, that's the plan. So if we wanted to go to a certain section, we're going to use the familiar block, the go-to block, like so. But we don't want to go to these coordinates. We want to actually tell it what coordinates to go to. We want to define the coordinates. And the coordinates are always going to be changing, because we're going to different parts of our circle. And the direction is going to be what changes our coordinates. Okay? If we scroll down our motion library, you'll notice X position, Y position, and direction. We're going to use this direction block. In fact, we're going to use more than one of these direction blocks. And they're going to go inside here. But what we need is, we need to do some calculations based on these directions, because the position we want to go to, that's going to be our result. Okay? And if we go to operators, we've got all these different mathematical blocks that we can use. We can pick random positions or random numbers. We can make decisions based on whether something is more than, less than, or equals to. We can use ands and ors, but we won't be going into that today. And then you've got your plus, your minus, your times, and your divides. If we scroll down a little bit further, we have this one, the absolute value of. We take that. We don't want the absolute value. In fact, what we want is, we want the sine, and the other one for the cosine. Okay, so now we've got sine and cosine of something. Okay, this is now where our little building blocks start to fall into place. Because what we want is the sine of our direction and the cosine of our direction. Okay, and Scratch will do the calculations for you, so you don't need to really understand what's happening now. But what will happen is the sine of any number is going to be between 0 and 1, and the cosine of any number is going to be between 0 and 1. But they're opposites to each other. A sine graph will start on 0 and go to 1, whereas a cosine graph will start on 1 and go to 0. Again, don't worry too much if that's confusing, if you don't understand that. All we need to know is that the result of this number and the result of this number is going to be between 0 and 1, which means we can take snippets of another number. Okay? And what we're going to do now is choose these multiply blocks. We've got sine in one and a cosine in the other. And essentially what we have now are two blocks or two equations, and if I change this, I'll just put the number 10 and 10 in both those just for a moment. What we have now are two calculations where this one will give you numbers ranging from 0 to 10. This one will give you numbers ranging from 0 to 10, which means it'll give us different points of the number 10, every single section of the number 10. Okay? Again, if you don't quite understand it, don't worry too much about what's actually happening. Here, we're not in business of doing complicated maths today. What we're trying to do is make a model. And in order to get a model of an atom, in order to get it to go into a circle, we're going to use these, because these two calculations allow us to choose or go to each individual section of our circle. Okay, and if I put the sine in my x, cosine in my y, and I press the green flag, what we notice now is, well, it looks like my electron has disappeared. It hasn't disappeared, it's just behind these two. Move in such a small circle that we can't actually see it. If I stop that, let's change these to 100. And then we click the green flag. Now you can see there's my electron and is moving in a circle. And what I want to do is I want to change this. It's not a circle. I want to make it more of an ellipse, like an oval kind of shape. Because in reality, that's the kind of shape electrons orbit in. And to do that, I just decide whether I want it to be tall and skinny or long and flat. Okay, and depending on which way I want to do it, I can change one or the other. So if I want to be tall, I'm going to change my x value, make my x value smaller, so let's say 50. I'm going to make my y value, so let's say 150. So now it won't move as much sideways because my x value is going to be smaller, but it will move further up and down because my y value will be bigger. So it should look something like this. Okay, and if I wanted it to go wider than it is tall, well, I just swap the numbers around. My x is now bigger than my y, means it will go further this way than it will this way, like so. Okay, and that's nice and simple. That's how we make our electron orbit our nucleus. Okay, like I said, maybe it's not the most accurate, and this is a bit more complicated than I made it out to be, but we're not trying to explain this today. That's not the purpose of our video. Our video is to explain or to make this rough model of an atom. Okay, and we've done that. And if we wanted to add a little bit extra on, what we could do is we can make our nucleus here, the individual bits inside, look like they're vibrating, because they don't sit perfectly still, just like how this electron doesn't orbit in a perfect ellipse. But for the purposes of this, that's what it's going to do. If I wanted to make it vibrate, I'd go back to my proton, and I would decide I wanted to actually move up and down just a tiny fraction. And also, I'd want to point in different directions. That way it'll be moving rather than going this way or this way. It actually sort of does in a bit of an erratic fashion. Okay, we'll keep our front layer there. We don't necessarily need it, but I'm going to keep it there. And I'm going to have move there, and I'm going to have a move there. 10 steps is probably a bit big, so I'm going to change to 1 and -1. You could have those the other way around if you wanted. And I'm going to actually tell it to point in a different direction. Point in direction, not 90, because that's the same direction all the time. That's just towards the right hand side of my screen. I want to be random. I'm going to go to operators, pick random, and 1 to 10, let's say 1 to 90. Okay, that way it'll move randomly in this rough direction, anywhere from up to right, so anywhere in this rough region. Okay, if I click the green flag now, you notice it looks like it's vibrating, it's shaking on the spot. And I do the same thing for my neutron. Right, so I'm going to copy this whole thing, so I'm going to take it out, hold it onto it, still have it clicked, and drag it down over here. It stays where it is on here, but now I go to neutron, I have everything I need here. Okay, what I don't want is I don't want to use the go-to, I don't want to use the front layer. I'm going to put my move in there and point in direction. This one though, because we've got two sprites or two balls stuck together to represent our neutron, moving in this much is going to be very noticeable. You'll see these start to move in odd fashions. So what we want is we want to make it much smaller. So let's say 90 and 95. Okay, so it's only actually moving 5 degrees, but it's going to stay with this orientation. There we go. Now it looks like our nucleus is vibrating while my electron orbits around. Okay, still a little bit tricky to see. So in the next video, we're going to go over how to use the draw tool. And we'll look at some little changes we can make with our orbit as well. So if you're fancy having a go and you want to play about with what we've currently got, be my guest. But when you're ready, come back to the next video and we'll go over how to add in the draw tool, a little bit extra thing we can do with the electron, and we can set an extra task.